I'm a co-founder of DeepLearning. I am wearing many hats on occasion, or actually every day. We are a startup based in Toronto. We're just up the street on Yonge Street. And what we do is we bring artificial intelligence to our enterprise partners. And one of the most important things that we do is help to bridge the gap of knowledge behind what artificial intelligence is capable of. And what we try to do is to find out what are the low-hanging fruits in artificial intelligence that can be applied in the business world. And we go ahead and co-develop these solutions with our partners. So I'm a practitioner myself. I'm an AI practitioner. I did study theoretical physics, but quickly switched over based on my computer science and statistics background into artificial intelligence. And one thing that I have noticed is that collaboration is the future of artificial intelligence in banking. That is the single most important thing that we have to get right, and that is how we can all benefit from technology such as artificial intelligence. So I'm going to press this green button. Hopefully it'll go to the next slide, and it does. So what does a collaborative future really mean? So there are many, many parts to it, and I don't think this is particularly unique to artificial intelligence. But I think with any emerging new technology, we need a collaboration between the people who are the experts in the technology and also the experts in the business or the subject matter. So that's one form of collaboration. The other form of collaboration is to have collaboration between industry and regulators, which is particularly poignant for the banking and financial sector. Artificial intelligence is going to introduce a lot of new ideas, new ways of doing things. And does it mean that we are going to change the ways that we have to regulate the models and the computers and the way that we go about solving problems? Maybe. And the way forward to make sure that we're not blocked and bottlenecked by that process is to have open discussions and honest discussions about those things. Now, the last thing about collaboration, I think that's probably interesting to many of you, is that AIs are not here to take over your jobs, or my job, hopefully. I think that the future, especially the immediate future and also the middle-term future, is that there is a collaboration between artificial intelligence and humans. The point of artificial intelligence is to augment. And this is very evident in many ways that artificial intelligence is currently applied to other industries. It's a way for humans to become better at doing what they're trying to do now. And I think Tiff mentioned earlier of the example of spreadsheets. Spreadsheets didn't come in to replace accountants. Spreadsheets came to enable accountants. In many ways, artificial intelligence should be striving for the same thing. And in fact, I think that the technological limitations currently with artificial intelligence is that it is going to be here to help us be better and to be able to help us do more interesting things so that we can leave behind some of the mundane things that we no longer need to do and that we can now ask the computers to do for us. So I think what we need to keep in mind for collective or collaborative AI future, there are many different components. I spoke about the general topics earlier, but there are some specifics that I want to get down to, and I really want to nail down and convey to you. Because I think collaboration is also part communication and knowledge sharing. And from my stance here as a practitioner who knows very little about finance and business compared to you folks here, I am here as a collaborator to tell you more about what artificial intelligence can do. So one thing to be very, very careful of, I think, is hype. And the reason why hype is something that is particularly important when talking about artificial intelligence is that it is all over the place right now. It's very sensationalized. If you Google artificial intelligence, you got tons of hits. Now, there's tremendous value in this because the excitement and also the amount of work that's being done is the ones that are underlying and generating this amount of content. And I think that is very healthy. It's a sign that there is something there. But at the same time, there's something very, very important about artificial intelligence and hype that's different from any other emergent technology that we've seen in the past in hype. The reason why is because the words and the language and the vernacular that we use to describe artificial intelligence is something that we're so very familiar with. We always talk about artificial intelligence. In fact, the word in itself, intelligence, is something so human that we tend to use those analogies to think about what artificial intelligence can do. And therein lies a problem. The problem being that if we start using these words, when are we pushing the analogies too far? We need to be cognizant that when we talk about artificial intelligence, when we talk about the fact that there's a chatbot, that there are limitations to what a chatbot can and cannot do. And so we just need to be very, very aware that some of the words that are used are in fact words that are going to be tricking us into pushing analogies too far. And when we start doing that, realities and expectations become mismatched. And that's when there is going to be a lot of disgruntledness when projects or software or products don't go the way they do. And so I think I have some practical ideas on how to deal with those issues, how to get to an elevated perspective on artificial intelligence and how can it apply. So I think one of the most important things to do right now is to go back to the one-on-ones. What is artificial intelligence? What are the basic ingredients of it, and how do we talk about it? And let me just clarify some of the words, for instance, that come up when we're talking about artificial intelligence, and try to distinguish those words for you. So you guys must have heard a lot about the word AI. Yes, I've said it about 50 times now. There are other words also in media that you hear about. Machine learning being one, deep learning being another. Are they synonymous? The answer is no. And so that's the first step. To understand that the blue there, the larger encompassing umbrella term, is artificial intelligence, and that machine learning is the how we can achieve artificial intelligence, and that's not the only way. It just so happens to be the most successful way so far. And the green there is a subdivision of machine learning called deep learning, also the name that we stole for our company, that has happened to have the most success in making sure that artificial intelligence can in fact achieve the level of success that we've seen so far. Artificial intelligence is a moving target, and I think that's a very important thing to remember. 20 years ago, Deep Blue beat Kasparov in chess, and that was pushing the boundaries of artificial intelligence 20 years ago. But if you were to ask somebody today whether that is a feat of artificial intelligence, they would have less of a conviction on that being a display of artificial intelligence. And this is because the bar of what we set a machine can and cannot do and what displays something more like human or not is constantly changing, is nuanced. We define it differently every day, and we keep pushing the boundaries. So what we say is artificial intelligence today may very well be different than what we say artificial intelligence is tomorrow or the next year. So when we talk about artificial intelligence, we tend to not use the word artificial intelligence. What we try to do is to be more precise and talk about what is called machine learning. And machine learning is a technology based in computer science and statistics and mathematical optimization that talks to the how. Artificial intelligence loosely talks about the what, but machine learning talks about how to achieve this kind of behavior. And so if there's one thing to take away from this talk, I think, are the four crucial ingredients to machine learning that currently, as we understand, nobody can get around. So these four ingredients now can actually be a sniff test for you when you are encountering people who talk about machine learning. So these four ingredients are as follows. So machine learning talks about computer programs that, number one, is told what the objective is. So there needs to be an objective that's quantifiable and defined. Then number two, the designer of a machine learning program needs to also tell it what the performance metric is. So it needs to say, after seeing what the machine is doing, how well it is doing. So that's number two. Number three is a general approach to solving the problem. Not the specific step-by-step recipe, but a general approach of how to get from the input information to the desired objective. So number three. And number four is the data. And the data you can think of as mock tests. So a set of mock tests that the machine is going to be evaluated against so that the machine can learn what was the right approach and what was not the right approach. So these four things is a good litmus test when somebody tells you, I have an artificial intelligence or machine learning solution to your problem. If they're missing any one of those four ingredients, chances are it's hype. So in deep learning, specifically, it is a form of machine learning that's inspired by biological neural networks. It is speaking of a particular approach. So for the 4 things that I spoke of, is targeting number 3. How do you approach a specific problem? So deep learning uses artificial neural networks that does the computation in trying to arrive from the data on the input side to the objective that you have defined as an AI designer. So deep learning has been tremendously successful. It has been able to do lots and lots of things that now we think of as the gold bar for what intelligence really means. So things like image recognition, artificial intelligence systems using deep learning have now been able to, in sort of sterile lab kind of condition, be able to beat humans in identifying objects in an image. It can also beat humans in recognizing voices and being able to transcribe audio information into text information. It is also beating humans in being able to translate from English to French to Chinese to Japanese. So those are some of the things that have been done in academia and have been done tremendously well using the technology of deep learning. So deep learning is, in fact, currently, as it stands, the most advanced form of artificial intelligence to power the functionalities that we like to see. So with all that said, now we can have a machine look at things. We can have a machine listen to things, talk about things. So it's not really that far-fetched to think that maybe general AI is coming around the corner. General AI being that we may one day have a piece of hardware walking around that acts and talks like a human. That is very, very far away. We're not even close to being able to do that. One thing I mentioned earlier about the 4 ingredients is that we need to be able to define a clear objective and also a clear way to measure how a machine is doing. Currently, there is no way for us, and we haven't figured out how to do it, how to measure whether a general AI, a human-like robot, is doing what they're supposed to do. We haven't been able to optimize life as humans. We can't help the AI figure it out. What is it that they should be doing in order to act like a human? We got pieces of it done because specific tasks are more of the realm of narrow AI. Those are specific things like image recognition. Here's a picture of a cat, say cat. They can do that. Here's a word, the, write down THE. They can do that. But they can't piece all that information together yet. We're not there yet. And so with that said, there are still lots and lots of opportunities where machine learning and artificial intelligence can help. So I'm going to switch gears a bit and start talking a little bit about how machine learning projects going on into the future, what the successful ones look like. And this is coming from experience that I have had when working with our enterprise partners and figuring out what is the most appropriate way to tackle some of these problems. And I'm going to come back to the theme of collaboration again. One of the most important things, I think, with machine learning is to start off with not solutioning. I think there are lots of people that I have spoken to that tell me that the right answer for them is a chatbot. That may be true, but I think there is something to be done and to be said about opening up the conversation with experts in artificial intelligence to be able to see what exactly are the business outcomes you're looking for. And I think it's crucial now, more than ever, with artificial intelligence, to really define what are the outcomes that you want. And the reasons are twofold. Number one, artificial intelligence and machine learning specifically now is able to do an end-to-end solution that was never a possibility using old technologies. Some of the bigger problems that we face now and that we have models for and machines for are typically broken down into stages. You have model A taking us from here to here, model B taking us from here to here, and process C that takes from here to here. Those are constructs by humans because of the limitations of technologies in the past. Now, deep learning and machine learning is able to blast through those blockades. We no longer need to follow the traditional paths. Not saying that every possible problem can be solved that way, but at least we need to be open about talking about those possibilities so that we don't block out potential, very powerful, and a possibly innovative way to solve problems. So I think especially from a risk perspective, there are many things that we can actually now try to assess and predict. That doesn't require us to use intermediate metrics or KPIs or ratios. There are many ways to capture more information in deep learning now than ever. So my suggestion, I think, is to open up that conversation from the get-go, to have the clearly defined business objectives first before diving into solutioning, because there are just so many possibilities now. Number 2, use your data now. I think that's very, very important because there's this classic chicken and egg problem where I think nobody has perfect data. And there's a hesitation in using the data now because you can always make the data better. So there are 2 ways to crack this cycle. One, you invest more money into making your data infrastructure or data intake better, and then wait for the future when the data is better and then you act on it. Or you try to do something with it now, that you take using machine learning to try to extract as much value as you can from the data assets you have now. And the advantages of doing that in the second way is that you immediately get something out of it. You get some value out of it, especially because machine learning now is more tolerant of data quality issues. There are ways around not so good data and unstructured data using machine learning and deep learning. So one thing that I think is very important is to start that process of trying to utilize your data assets immediately rather than waiting until it is perfect, because it will never be perfect. And the sooner you start, especially when you take a phased approach to problem solving, the sooner you realize what your limitations are for data, and the sooner you can start doing this in an iterative fashion to improve your data assets while gaining value out of it along the way. So this is what I touched earlier, which is taking a phased approach. I think taking a phased approach is especially important with using new technology like artificial intelligence and machine learning. And the reason why is pretty obvious, I think, to all of you here, but maybe it is worth taking 2 seconds to talk about, is the fact that there are inherent risks in using new technology. No AI expert in the world would be able to guarantee you an outcome until they try. And the way to go about mitigating that risk is to make sure that we take bite-sized chunks of a problem to try to get to the end result, not in one big step, but in many small steps. And I think especially when it comes down to the world of finance, where there are many different stakeholders and parties involved, getting everyone into the same room and figuring out what those bite-sized chunks are and being able to achieve those gives you momentum when you do succeed on those small steps, and gives you the confidence that there are ways to go forward and to solve the problems that you have. And I think that comes down to having a good team. And I think there are companies out there right now who are trying to take the approach of just using, putting a bunch of PhDs together and lock them in the room and hope for the best and get an answer out of it. And I think AI solutions are more nuanced than that. And I think it is one of the things that is trying to address the deficiencies of big data and the promise of it, which is, at the end of the day, you need to have a product that you will be able to release, a solution that you'll be able to integrate, and a solution that you can put out into the market or deploy within your own operations. So what that means is that you need a cross-functional team. You not only need AI experts, but you also need technologists, you need engineers, you need also business users and stakeholders to be in the same room so that they can talk the same language. One good example here is that image recognition. So it's actually a anti-example, but I'll make that clear a bit. Image recognition. So they locked a bunch of AI experts in the room doing PhDs, and they figured out how to do this well. And they didn't need any subject matter expert because the AI expert knows what it means to do image recognition. They are one and the same. The subject matter expert in that case is exactly the same person as the AI expert. The human knows how to look at the picture and recognize what is a cat and what is not. However, when you start crossing the boundaries from academia into more industry-specific problems, the AI expert no longer is a subject matter expert. It is very important for that collaboration to happen because the business users or the subject matter experts may not know the capabilities of artificial intelligence, but they know the business well. On the other hand, the AI experts will be talking a complete different language, and they need to sit in a room to hash out what is in common and how to move forward from there. To understand the problem from both perspectives is very important, and that can only come about when we have agile cross-functional teams. The last thing I think that's very important, which actually goes back to the slide earlier, is about finding the right tools. Finding an AI solution is not as simple as writing a model and then calling it a day. It's about packaging it so that it is a good solution for your enterprise or your business unit, and how to inject that into your operations and your process. And I think that is one of the failings of big data in the past, and right now machine learning is here to try to rectify that. The right tools here help you in all three of these elements. And the design element, designing the problem, getting the requirements right. The right tool helps you develop. So make sure that the development of these machine learning solutions is quick and is also efficient. And the last thing, and the most important piece, the right tool also helps you deploy your solution in the right time at the right place. So those are the 5 important things, I think, for a successful AI project. So now we get to some of the use cases. And here's a bit of a disclaimer. I earlier talked about hype, and I earlier also talked about how artificial intelligence as a broad term may be very vague. I think what I'm about to say you need to take with a grain of salt, simply because I myself alone is not creative enough and imaginative enough to be able to foresee what is going to happen with artificial intelligence. I imagine myself standing here being in the position of the person who has designed a spreadsheet, being asked on the day that it was released to the world, what can you do with a spreadsheet? There's no right answer. But I can definitely point you in the right direction and tell you some information about what is possible as I see it now. And I think that's going to be very important. One thing Professor Andrew Ng from Stanford, an AI expert who headed up both Google Brain and Baidu, has said one thing, and I think it's quite true. So this is one thing that you can take away and try to imagine how it applies to your problems. He said, and I'm paraphrasing here, any problem that a human can do in under 10 seconds that you can't currently automate in a simple manner with existing technology is probably an artificial intelligence problem that you can try to solve. So that's a good metric. But what are some of the other things that you can do? So earlier Tiff has mentioned prediction. Prediction, it is the basis of everything that artificial intelligence system does and what machine learning can do. Prediction means that we have some temporal aspect to the information. We have some information in the past, and we're trying to get at what the information will be in the future. There are many, many applications here. With machine learning and deep learning, the information that you're ingesting and also the information that you are outputting are not necessarily limited to numerical data or textual data or even image data. There's voice, there's geospatial information, there is internal measurements of how your processes are working, for instance. Those are all possible things that you can throw at a machine learning algorithm and have it try to reach the objective that you're trying to define for it. So with prediction, one of the important ways of going about doing this is something called supervised learning. And supervised learning is simply an approach where using the mock tests, you actually also give the machine what the true answers to those mock tests are. And in other words, you are giving the machine examples of what is right so that the machine can learn through the training period of what is the desired output. Now, here are the cautionary tales about using supervised learning and prediction. And 2 of the main important ones are as follows. Number 1 is that prediction usually does not mean causation. So this is a fundamental thing about statistics, that correlation does not imply causation. But I think in the guise of machine learning and artificial intelligence, it's especially important because it may seem like there's an intelligent being doing something, making these causal kind of relationships in its head and trying to make a prediction in the future, whether it be in customer behavior or market behavior. But that does not imply that the information that you've given it is necessarily causal. There are approaches to try to figure out whether those effects are causal or not, or just pure correlation, or something more nuanced. But as a general stance, I think we need to be careful when interpreting the results of a predictive algorithm and not to think that they are necessarily causal. Number two is that when you give examples in the supervised learning way of dealing with things, giving examples to the machine to tell it what is right and wrong, you're exposing the machine to the very same bias as you have done in the past. So if whether your staff or your models in the past have decided that answer A was the right answer, but it turns out that it has embedded some bias within it, then your new machine that you're training using machine learning algorithms on that data will also acquire the same bias. So we need to be careful about those biases and how we can eliminate that. It just takes some thought. It's not that it's impossible. It's that it's not as simple as just throwing information into a black box and getting an answer. We need to be careful about this. So one example of using prediction is doing prediction of default, whether it being on the customer level, whether it being on the account level, whether it being on a business level. There are ways to take information about how past accounts or entities have performed, what their behaviors are, and how it relates to their defaulting behavior into the future. And I think that is one of the most straightforward way to apply this prediction model. And there are other ways of going about a similar problem. Segmentation is one extreme example that I think is very interesting and ripe with possibilities. So segmentation, I think you are all very aware of what that means, especially when it comes down to customers, when it comes down to a general population. But using deep learning and machine learning now, there are ways to ingest even more information and more data than the past. And that is a very powerful way to make hyper segmentation, where now your segments are not necessarily as large as they were before, and you can do personalization tactics to go about doing things like recommendations and trying to learn the different population and how they shift and the dynamics of them. So one cautionary thing about segmentation is that a lot of times you don't really know what the segments are, and you're trying to ask the machine to seek those segments. And that would fall under the paradigm of unsupervised learning, and there are some limitations to unsupervised learning. Unsupervised learning is nowhere as developed as supervised learning in the predicting scheme. So therefore, the performance of it will be necessarily different than a supervised learning way. So that doesn't mean that every problem that we try to do segmentation will be unsupervised, meaning that there is no correct answer. That just means that we may have to be more creative about finding out what those segments are ahead of time to help the machine learn better. So I'm going to skip past talking specifically about the use case there, because I want to get into something called reinforcement learning. And reinforcement learning is something that is extremely, extremely interesting and very is starting to become closer and closer to what we imagine a human does in their development cycle. So reinforcement learning is a scenario where you don't provide the machine with the correct answer necessarily during those mock tests. What you do is you actually just give them rewards when they did the right thing. So in other words, you might not necessarily know what the correct answer all the time is, but you do know that whether it is going down the right path or not. And through this reward mechanism, the machine will be able to tease out what are the paths to take in order to maximize and optimize for the end objective. And some of the incredible things that have happened in the reinforcement learning area is in the areas of video games. So video games, for instance, even as a human player, you may sometimes not know what the optimal path is. So you can only be certain that you're gaining score or losing score as you progress in the game. So using reinforcement learning coupled with some other technologies as well, researchers have been able to use this, the score of a video game, to train a artificial intelligent machine to be able to beat Atari games and to be able to perform it at superhuman level. So that is something that's incredibly exciting, and I think there's lots of room to try to apply reinforcement learning in real-life scenarios. But one cautionary tale with reinforcement learning is that currently it requires a lot of patience, I would say. There's a lot of tweaking to make sure that the machines are being incentivized to do the right thing. In the sense of video games, it's easy because scores are well defined, but in real life scenarios, what is considered to be the right amount of reward and what is considered to be the right amount of penalty may not be very obvious. So that is one thing that you'll need to be aware of. And second thing about reinforcement learning that is also troubling, or not troubling so much, but something that you need to be aware of is that these systems are going to be constantly learning. And so there needs to be good governance structure around it to make sure that it doesn't go out of bounds, if you will, that its behavior is bounded, and that we have ways to control when it does get out of hand, or ways about it to push it back on track. So those are a couple of things I think reinforcement learning is very exciting about reinforcement learning, but also some of the things that we need to pay attention to. So one case is fraud detection. As fraudsters become more and more sophisticated, the way that they behave will be different. And so there's a way for reinforcement learning to help in dealing with that dynamic system, to learn about the way that they are caching fraudulent behavior, and to be able to adapt to the way that the environment and people change. So I'm going to end off with stating some of the things that I've talked about already, which is how should we react to artificial intelligence in the area of banking, and how do we move forward so that we are guaranteed a success. I think one of the most important things is to make sure that we embrace collaboration, because artificial intelligence is a very complex field involving many, many skill sets, and the only way forward really is to make sure that everybody has honest and open discussions about what its capabilities are, what it can and cannot do, and also to be able to understand what the pain points are in a deeper and clearer way. Another thing to make sure that we do is to make sure that we take phased approaches to problems, and to open up the ideation session so that you can figure out other approaches that have never been thought of before using traditional means. And start now, and start small, but think big, because that is very, very important in making sure that you leverage the data assets you have now, and to make sure that we are getting somewhere that is going to be innovative and world-changing. And find the right talent for you. Getting the right people into the room is the most important thing to make sure an initiative is successful when it involves artificial intelligence. And the last thing, pair up your talent with the right tools. Make sure that the tools enable your talent, just like how in the future, AI is going to be enabling ourselves in doing things better. And that is all. Thank you.
So perhaps unbeknownst to you, we actually had shorter slots after lunch. So we'll have time for one question, but then we'll be moving on to the next session. I do have a series of people who've sent in questions. No burning ones here. So in your view, what are the moral hazards of artificial intelligence?
So I think the one thing that I touched on would be on the supervised learning parts. So the moral hazards there is the fact that when we provide examples to the machine to train off of, we have to be really, really careful about making sure that those examples are moral examples or ethical examples. That's one area. Another area is, I think, on a larger scale, when we do start approaching things that are closer to revolutionary, like autonomous vehicles, there are societal impacts and policies that we need to make sure that we have the conversations now rather than it is being too late. So I think those are the two major areas.